Yeah. So good evening, everyone. Good evening. Good evening. Let me know audio video okay or not. Check once audio video okay or not. Right. Yeah. So today we are starting right graph theory. So I think as I mentioned to you yesterday, discrete mathematics we are starting. We are starting the discrete mathematics. For the gate CSE people, gate CSE and DA people. Right, discrete mathematics we are starting gate CSE people and gate DA people. Right. So in that the first one which we are starting is graph theory. We are starting the graph theory. First one we are starting is graph theory. So I think if you observe clearly this graph theory, minimum 2 marks you will get, maximum 4 marks you will get, minimum 2, maximum 4, on an average 3. And this graph theory you may see it is required for graph theory also, right? That is okay, right? Algorithm also it is required, data structures also it is required, sometimes in the operating system also, sometimes in the DBMS also, somewhere required. But majorly in algo most of the time it will come, data structures also most of the time it will come, OS and DBMS some places it may come, right? But anyhow this is the one of the favorite topic of computer science and DA and computer science. It is the favorite topic. Minimum 2, maximum 4 marks you can expect. This is the first chapter of discrete mathematics. Yeah, we are starting now. We are starting. So graph theory, let me start. In my opinion, today's class is just started now. Let me write that date also. I think 16, 12, 25. Yeah, you people may say that, right? Until now, what dance you are doing? Where are you dancing till now? You may ask that. Class is at 7:30. You are coming at 8:30. You are teaching so seriously. You may ask that, right? So, but unfortunately, I think it is a traffic jam. I'm really sorry. Unfortunately, it is a traffic jam. That is the reason I am unable to start correct time. I'm really sorry, right? I think tomorrow onwards I will take care. So because of traffic jam, it became delayed, right? I'm really sorry for this. Yeah, I hope we can go ahead. Please let me know if anyone say no, sir. No, sir, the time is over. Then we will start tomorrow. If you say okay, we can start now also, right? Let me know this. So unfortunately, the right traffic jam that may be the reason I am starting like this. I'm really sorry. So we can start now. Can we go ahead? Yeah, let me go ahead. Many people are saying go ahead. So that is the reason I'm starting. So go ahead now. So 16, 12, 25. This is the today's class, right? Today's date. In my opinion, class is just started now. Right now, graph theory. Right? In that first one, graph. So graph G is the combination of V and E. Careful everyone. I'm just started now. I just started now. Graph theory. So I given date also. See this one. 16, 12, 25. 16, 12, 25 is the date. So graph theory started. So graph G is the combination of V and E. Graph G is the combination of V and E, where V is set of vertices. V is set of vertices. E is set of edges. V is the set of vertices, E is the set of edges, right? Let me give one example. I'm taking one example. A, B, C, D. A, B, C, D. You can keep the name as some name, graph G1, assume. Whatever name you want, you can give. Graph G1. Right? So this is the graph, name is G1. Now I am listing out here vertices. What are the vertices here? Now if you see the vertices in this graph, circles are called vertices. A, B, C, D. Next one, if you see the edges between two circles, one line is there. That is called edge. So it is a edge E1. You can give whatever number you want. It is the edge E2. It is the edge E3. It is the edge E4. It is the edge E5. Let me write. Edges E is equal to E1, E2, E3, E4, E5. So be careful. So graph G is the combination of vertices and edges. Vertices is nothing but vertices is also called as nodes. Vertices is also called as nodes. Right? So the circles are known as vertices. Right? Here four vertices are there. Between two vertices, one line is there. That is called edge. So E1 edge, if you observe clearly, E1 is from A to B. Now you can write like this also, A to B. So E2, if you observe, I think there is edge from A to D. So like that also you can write. So next one, I think E3, if you observe, C to B or B to C, it doesn't matter because there is no direction. So C to B also you can write, B to C also you can write. Anything is fine. If you see the edge E4, I think A to C, C to A also okay. If you see the edge E5, see the edge E5, C to D also okay, D to C also okay. So I'm not done anything. I started the graph theory with the definition. What is graph? Graph G is nothing but combination of vertices and edges. Graph G is nothing but a combination of vertices and edges. So one example I given. It is a one example. Example one. So these are the vertices. These are the edges. So every circle is known as vertices. Between two circle, one line there, that is called edge. This is the example one. Let me know if anyone having any objection. Ready, sir? I have this doubt. If you have doubt, you can ask me. Sir, I have this doubt, sir. You ask me, I will help. Any doubt? So I started here. See, I started here. What is graph? I started here. What is graph? Right? So graph G is nothing but a combination of those people who are having small doubt also. If you have small doubt also, until now, if you have small doubt also, see this one. What is graph? I started. Graph theory I started. What is graph? Graph G is a combination of V and E. It is a combination of V and E. What is V? Set of vertices. What is E? Set of edges. So circles are known as vertices, A, B, C, D. Right? Between two circles, one line there. Right? That is called edge. So edges are, if you see, E1 to E5. So E1 is A to B. E2 is A to D. Right? Next one. So E3 is B to C. E4 is A to D. Sorry, A to C. E5 is C to D. So like that. I hope everyone is comfortable. I hope everyone is comfortable. Now it's okay. So one right graph definition, very simple combination of vertices and edges. One example also I given. Okay, fine. Now we can move to the next one. Can you see the next one? Example 2 also take. Take example 2. A, B, C, D, E, this is the second example. Careful, everyone. This is the second example. So if you see the vertices here, A, B, C, D, E. If you see the edges here, let me give randomly. E1, E2, E3, E4, E5, E6, E7. So no, that is E7 already there. E6, E7, E8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, totally 8 people. Let me write E1, E2, E3, and so on, E8. You know, graph is the combination of vertices and edge. And this graph name, you can keep whatever name you want. This graph name is G2. What is the previous graph name? G1. This graph name is G2. Vertices are going to be A to E, edges are going to be E1 to E8. Between two circle, one line there, that is called edge. Right? I hope everyone is fine. E1, E2, and so on, E8. This is the second graph. Okay. I think until now we done the two examples. Okay. Let's go to example 3. Everyone know? If anyone don't know, please be careful. E3. Example 3. Sorry for this. Example 3. A, B, C, D, E, F. So this is the graph. Name is, I think you can write whatever name you want. Let me write. It is the graph G3. So if you see the vertices here, A, B, C, D, E, and F. I think 6 vertices. If you see the edges here, so let me give some other color. I think I'm using white color. So let's say E1, E2, E3, E4, E5, E6, E7, E8, E9, E10. Check if any edge is missing. E11. I think every edge is covered. Check. Yeah, I think 11. So E1, E2, E3, and so on, E11. So 3 examples I given. Very simple. I am not done anything. Just today, as soon as I started the class, can you see this one? Right? I written the date 16, 12, 25, followed by what is graph, combination of vertices and edges. So I took the first example, right? Graph G1 I took. So circles are called vertices. Between two circle line is there, that is called edge. So in the first graph, I think if you observe clearly, 4 vertices and 5 edges. Right? In the second graph, I think 5 vertices, right? Edges are, I think, 8. Check properly. Every line is called edge. So G2 graph, vertices are 5, edges are 8. If you go to the right graph 3, I think graph 3, G3, vertices are, I think, 6. Edges are, I think, 11. Right? Every line is called edge. If anything missing, I will definitely cover it. Don't worry. Let me know till now, are you comfortable or not? Let me know till now, are you comfortable or not? Is there any doubt? Till now, do you have any doubt? Check everyone. Till now, do you have any doubt? Sir, I have this doubt. You ask me if you have doubt. Do you have any doubt till now? Check everyone. Please let me know small doubt also there. Okay, if you don't have any doubt, yeah, you can move to the next one. You don't have any doubt, you can move to the next one. Observe here. Example 1. Observe here. Example 1. Observe everyone. If you see the example 1, so I have to use some other color. So I think I may go for the white color. White, can I go? Yeah, I think purple color maybe I'm going. Now see, observe. So right, 3 graphs I written, right? 3 graphs I given, 3 examples also I given. Now go to inside, check properly. Go to inside, check properly one important thing. What is that one? For the vertex A, if you observe clearly, 3 edges are associated. For vertex A, in the example 1, for vertex A, 3 edges are associated. It is a 1 edge, it is a 1 more edge, it is a 1 more edge. For the vertex A, right, if you see the vertex A, 3 edges are associated. That is called degree. Let me write now. What is the degree definition? Can you see this one? Degree of A is equal to number of edges associated. Number of edges associated. Number of edges associated with vertex A. Number of edges associated with vertex A. I think if you observe clearly, degree of A is 3 edges are associated, degree of A is 3. If you see the B, I think only 2 edges are associated, so degree of B is 2. If you see the C, 3 edges are associated, degree of C is 3. If you go to the D, right, 2 edges are associated with the D, so 2. So in this example, if you observe clearly, in the example 1, every vertex degree I already computed. So to do the same thing, let's go to example 2. That is the reason I given 3 examples. Let's go here. Let's go here. What is the degree of A? This is a way of representation. Degree of A means how many edges are associated with vertex A. Check properly. I think 3. Degree of B also check. Degree of B, if you observe, I think 3 people. Degree of C also check. Degree of C also check. So 3. Degree of D also check. I think 3. Degree of E also check. I think degree of E, if you observe 1, 2, 3, 4, 4 people. Check if I done anything wrong. A 3, okay. B also 3, that is also okay. C also 3, that is also okay. D also 3, that is also okay. But E is, I think, 4. E is, I think, 4. Also, until now, everyone is comfortable. Right? I think a degree is also fine. What is the meaning of degree? Degree of a particular vertex is nothing but the number of edges associated with that vertex. I think vertex A is associated with 3 edges. Vertex B is associated with 3 edges. Vertex C is associated with 3 edges. Vertex D associated with 3 edges. Vertex C associated with 4 edges. So like that. Okay, fine. I think you are comfortable. So example 2 also we done. Let's go to example 3. Understand here. Understand this also. Right? If you go to the example 3, what is the degree of A? Check. Degree of A is 3. What is the degree of B? I think 4. What about degree of C? Degree of C, 1, 2, 3, 4. I think 4. What is the degree of D? Degree of D, 1, 2, 3, 4. Next one, degree of E. Degree of E, 1, 2, 3, 4. Degree of F. Degree of F, so 3. So every person degree also we computed. Till now, everyone is okay. Now to give the one more clarity, I'm giving one more example. Can you see the one more example? Example 4. Observe clearly here also. Example 4. A, B, C, D, E, A, B, C, D, E, A, B, C, D, E. So observe here, A, B, C, D, E. So let us assume that this is called self loop. I kept self loop also. Let us assume that B to E, one edge there, I am keeping one more edge. So B to E, already one edge there, I am keeping one more edge. Those are called parallel edges. Those are known as parallel edges. So I think if you see B to E, three edges are there. They are parallel to each other. And one more thing is at the C, I am keeping self loop also. Right? So remember, it is also a graph. Graph means what? Combination of vertices and edges. Let us assume that this graph name is, assume G4. Graph name is G4. Let's observe one by one. Vertices how many? A, B, C, D, E. A, B, C, D, E. Vertices are A, B, C, D. Okay. What about edges here? So let's go to edges. I'm giving the labels also. I'm giving the labels also. It is a E1. It is a E2. It is a E3. It is a E4. It is a E5. It is a E6. It is a E7. It's a E8. E9. E10. E11. E12. Check if any edge missing. Every edge you have to give label. Every edge you have to give label. I think if you observe clearly, totally 12. Totally 12 edges. Can you check? So E1, E2, E3, and so on, E12. Okay, till now comfortable. Vertices okay, edges okay. Now observe. What about degree of A? Check. Degree of A. If you observe clearly degree of A, the number of edges associated with A. Remember, it is one edge. It is a one more edge. It's a one more edge. It's 3. It's a one more edge. It's a one more edge. Remember, this A don't know that same person is coming back. So self loop will count degree by 2. 2 plus 3, 5. What is the degree of B? What is the degree of B? Degree of B, if you observe, 1 here, 2 here, 3 here, 4 here, 5. 5. What is the degree of C? Check. Degree of C. 1, 2, 3, 4, 5, 6. What is the degree of D? Check the degree of D. I think 3. Degree of E. Degree of E, if you observe, 1, 2, 3, 4, 5. So like this degree. So I want to say one important thing, right? Self loop will count to degree by 2. Note, self loop will count, will give degree 2. Self loop will give degree 2. Remember this one. Self loop will give degree 2. But in the previous problems, there is no self loop. Check. In the previous problem, there is no, in this one, there is no self loop. It became so easy. There is no parallel edges also. That is the reason third example became so easy. Second example also, there is no parallel edges, there is no self loop. It became so easy. If you go to the first example, no parallel edges, no self loop. That is the reason it is also became easy. Right? Remember what is the degree? Degree of a particular vertex is nothing but how many edges it is associated. The number of edges associated with the vertex A, that is called degree of A. So we computed degree of A is 3, degree of B is 2, degree of C is 3, degree of D is 2. Similar way, example 2, degree of A is 3, degree of B is 3, degree of C is 3, degree of D is 3, degree of E is 4. Let's go to example 3. Degree of A is 3, degree of B is 4, degree of C is also 4, degree of D is I think 4, degree of E is 4, degree of F is 3, like that. If you go to the example 4, which look little difficult, example 4 look like difficult because there are self loops also there are parallel edges also there. If you see the degree of A, I think one self loop is there. So degree 2 plus 3 more. 2 plus 3, 5. If you go to the B, no self loop is there, but 3 parallel edges. 3 plus 2, 5. Edge, right? If you go to the C, I think 4 plus 2, 6. One self loop, 2, 4 more edges, 6. If you go to the D, I think no self loop, no parallel edges. So 3. If you go to the E, 3 parallel edges plus 2, totally 5. Self loop will give degree 2. So fourth example also we done. Do you have any objection? Anyone having any objection, let me know. Anyone having any objection, let me know. Check everyone. 4 examples I given. Right? Perfect. I'm thinking that you are absolutely fine. I'm thinking that you are absolutely fine. Let's go to one more important thing. Everyone observe. So I'm starting with the example 2. I may use another color also. I'm using white color. Can you see this? Everyone try to understand. White color I am using. Maybe I think I will go to the yellow color. Let me go to the yellow colors. Can you see this? So if you count the sum of degrees, sum of degrees, let's count. 3 plus 3, 6. 6 plus 4, 10. 10 plus 3, 10 plus 3, 13. 13 plus 3, 16. So let's see this one. Sum of degrees. Observe everyone. Sum of degrees, which is equal to 16. This can be written as 2 into 8. Sum of degrees is 16. 6 plus 4, 10. 10 plus 6 is 16. So 16 can be written as 2 into 8. Remember, this 8 is going to be number of edges. Count if you want. Number of edges. Right? Let me check. See, number of edges are 8. E1, E2, E3 and so on, number of edges. Right? Remember, sum of degrees are nothing but 2 into E. Sum of degrees is nothing but 2 into E. This is called sum of degrees theorem. This is called sum of degrees theorem. To get the more clarity, can you go to the first example? See the first example. Sum of degrees. 3 plus 2, 5. 5 plus 3, 8. 8 plus 2, 10. So sum of degrees is 10. 10 can be written as 2 into 5, where 5 is the number of edges. I think 5, right? 5 edges. See, 5 edges are there. So I think first example also okay. Let's go to third example. Can everyone observe? Can everyone observe? Sum of degrees. Let me check. 3 plus 4, 7. 7 plus 4, 11. 11 plus 4, 15. 15 plus 4, 19. 19 plus 3, 22 is equal to 22 is equal to 2 into 11. This 11 is number of edges. Can you count? So from this conclusion, sum of degrees is equal to 2 into E, where E is the number of edges. This is called sum of degrees theorem. This is called sum of degrees theorem. Remember, this will be valid for, right, a graph which contains self loop also, a graph which contains parallel edges also. Please remember, if you want, you can check this. If you want, you can check. 5 plus 5, 10. 10 plus 6, 16. 16 plus 3, 19. 19 plus 5, 24. 24, which is equal to 2 into 11. Right? It's 24. 2 into 12. 2 into 12. Where 12 is the number of edges. Right? So from this conclusion, right, this is called sum of degrees theorem. This is called sum of degrees theorem. So let me write here. Note. It's a very, very important one. It's a very, very important one. Can you see the note? Note 1. Self loop will count degree as 2. That is a one point. Okay, 2. See the second point, very, very important. Sum of degrees is equal to 2 into number of edges. This is also can be written like this. See this one, sigma I is equal to 1 to n, assume n vertices, degree of vi vertex I is equal to 2 into number of edges. This is called sum of degrees theorem. These two nodes are very, very important. Remember 2 into E means what? Even. Sum of degrees is always even. I'm not saying number of edges are even. Sum of degrees are even. I'm not saying that edges are even. Always edges are even. I'm not saying. Sum of degrees are even always. 2 into E means what? Even number. Sum of degrees are always even number. You may say that, sir, why even is coming? So see this one, why even is coming? AB, listen, AB, if you draw one line, degree will become 2. Check. If you draw one line, degree become 2. Why? E will also count, E will also count. Every time one edge will give 2 degree. If at all 5 edges are there, 5 into 2, 10 degree. If at all 20 edges are there, 20 into 2, 40 degree. So every edge will bring 2 degree. So that is the reason sum of degrees are always even number. Even number means 2 into something you can write. Right? Okay. I think you got it. Till now, if you are comfortable, right? I'm stopping here. Till now, if you are comfortable, I'm stopping here. Tomorrow I will start. Right? I will start. Today, unfortunately, little late. I'm little late. So I'm really sorry for this. Right? I'm stopping here. I just given 4 examples followed by 2 notes I given. And 4 examples. So those people who are aiming for 2027, if you are aiming 2027, you can go for 2027 people can go for regular course. 2028 people can go for foundation course. Right? So next one, crash course, right? This is for maybe those people who are, right, 2026 people maybe can check it. And those people who are 2026 people, practice course, it's a very, very important for 2026 people. So if you have any doubt at any point of time, if you need guidance, you can go for mentorship course. 2026 people can go for the test series. Approximately 100 tests are available. Right? Yeah. Next one, why exam prep tool? Many people may get the doubt. Why exam prep tool? Recorded is there, live also there. Daily quizzes also there. Doubt solving, 24/7 doubt solving is there. Gate PYQs, 3000 PYQs with solution. 6000 verified questions also totally, right? So you will get a lot of practice questions. Trail courses also there. All right, personalized guidance also there. Mentorship with the toppers and myself. And AIR1 notes also we will provide. And one more thing is, right, so we will give that, right, mentorship sessions also. So everything, whatever job notifications also we'll provide the, right, simultaneously we'll provide the placement assistance also, right? So in every manner we are going to help you. So right, so that is the, these are our toppers, right? Next one is, yeah, for I think perfect. Tomorrow sharply I will start 7:30. Sorry for inconvenience. And one more thing is 80% offer going on, you can utilize. Those people who are serious, they can go for 80% discount is going on, you can utilize. Thank you. See you in the next class.